Hello everyone, I hope you all are doing really well. Saboni this side. In my previous videos, I have talked about different Kubernetes components and pod was one of them. So just to revise, what are pods? They are the smallest deployable units that where you can run your applications, right, as a Kubernetes workload. So pod basically acts as a wrapper around one or more containers that you are running, along with a shared storage, network resources, and certain specifications. This video, I'm going to talk about different ways you can run containers, basically in a multi-container environment, how actually you can use. And the one that I'm going to cover mainly is about init containers. So talking about init containers, what are init containers? So think them as the setup screw that comes in and does the necessary preparation work and leaves before the main show starts. So whenever an application, you are, say for example, this is your application, you actually want to do some kind of pre-existing checks before bringing this application up, then in that case comes the help of init containers. The main role is it performs the initialization and set up certain tasks for the main application containers. If I talk about what's the lifecycle of init containers, so they run sequentially before your application container and they must complete successfully before your application is up. And once they complete, they terminate and do not run again unless you have specified or unless the pod itself is restarted. And if an init containers fails, the pod is marked as failed and main containers, they never start. If I talk about the use cases are mainly waiting for a dependency, like if you are polling an external database or a service until it's ready, so you can use init containers who can do the task on your behalf. Any kind of configuration setup, if a config file or a secret, anything is there available in a secured location, and you can use init containers to preload that in the shared volume of the pod so that your main application can access it. Any kind of permission setup, so running of a shell script to set up necessary file permissions, etc. before your main application can begin, right? So that's what your init containers are for. So init containers, you can have a chain of multiple init containers you can use along with the app containers. So if I show you this, so they are executed sequentially, and finally all of them, when they have exited or terminated successfully, then only your application container starts. So this is the official Kubernetes documentation where you will get a lot of information about init containers. And there is another concept of a sidecar container where I will talk about it later, but just to give you a flavor, it's similar to init containers, but they continuously run along with the main application, providing additional features and support. So there are certain, we'll talk about the difference between the sidecar containers, init containers later, but let me show you a demonstration. So I'm running a Minikube cluster on my local. So if I show you what are the available all pods that are running, which are running under the kube system, mainly core DNS, etcd, kube API server, controller, proxy, scheduler, and the storage provisioner as well. So these are additional important components of the control plane. So let's now try to create a YML. Okay, so I will use this kubectl run. So I'm going to use an imperative way of approach in order to create a pod. But before that, I will just try to create a template and then we'll modify and see how it works. Okay. So kubectl run followed by a name. The name that I'm going to give, say for example, app with init. And for the image, let's try to give, say nginx, for example. And this is something that you need to add, dry run equal to client and -o YML. So this is actually quite similar to a dry run that you are doing, and it's not actually hitting the kube API server. That this is what I'm expecting, but it's more of at the client level you are running it, you're not executing it, just to ensure that your YML file is successful, like there's no issues with the YML creation. So before creating that, so let's just try to save it somewhere. Init container pod.yml. So this is the file that got created over here, and if I just minimize it a bit, so this is what my file is. So just let's try to change the labels over here, and I don't need any creation time, and let us try to remove this DNS config and resources. All these things are not needed for me, and say the name of this main container, let me try to give as main app. Okay, and so how you specify an init container? So you specify an init container as, sorry, init containers, and here I'm just giving I've just used Amazon Q along with me, which already have it. The plugin is already installed, but like it auto completed it. But the image, say for example, I will be using as busybox, and the name I'm going to use is, for example, init script. What do I want is what I want is to this init container to perform an echo statement, and what it will do, for example, the init container is running, so it will print that. But let us try to save it to a file, say at a location data/init.txt, and oh, there's a single note over here. And what we will do over here is we'll create a volume. Okay, and this volumes, for example, I've just used the name of the volume as shared data, and this volume would be mounted to both the init container as well as my main container application, because I want this to be saved somewhere in the init.txt, and my main application container would be trying to access that txt file. Okay, so over here, let us try to use, since it's an since it's in this init containers, under here I will try to use volume mounts. So this is how actually you can locally create a volume for the pod, but if you want to mount it on top of any container, so for init containers or even for containers, you can use this keyword under spec, which is volume mounts, and over there you just pass a name over here. The volume mounts name is basically the same name of the volumes that you have created, and over there you are just specifying the mounting path here. This is the mount path. Okay, so similarly there would be this volume mount for here, but one thing is the mount path which I'm trying to specify over here is user/share/nginx/html. Since it's an nginx image, I want this to be accessible over port 8080. If any other application is trying to access it, it would be able to get this text file if they try to access it, perform an internal curl statement, etc., or just simply try to access the application. They can quite easily do it. That is overall looks good. So just to final check, under to both my init containers and the containers, it would have this volume which is I have specified that would be mounted, but only the mounting paths would be different. Okay, so let's try to execute it. kubectl apply -f and this YAML file. So it got created. So kubectl get pods. So if I try to see that this is now running, but had I been faster, like its age is 6 seconds, had I been faster, the status would have been different. Let's try to see kubectl get pod app with init and -o YML over here. So if I show you over here, you will find the various statuses over here, right? So initialized, so first it shows what are the conditions, what are the status. So pod ready to start container, and then it shows that it's initialized, it's ready. So these are in the reverse chronological order, if you could see. So the pod, these shows the status of the overall pod, whether it was initialized, the pod got scheduled, then the containers were readied and it is ready, then it is initialized in order to get the traffic. So it's all randomly shown possibly over here, but for the transition time that is shown over here, you can monitor the conditions and the different status of it. And here if I show you the init container, so this is where the status of init container is. So if you see that my init container got successfully executed, and over here it's completed, it started at this and finished at this, so within a second it just completed, and the exit code status shows as 0. So that's the successful. And after that only my actual container got started. So 18, 19, 11 it shows, and here my init container got executed at 18, 19, 10. So initially whenever you try to deploy it, it shows initialized and then 0/1. So we'll try to add another statement over here, and we'll try to rerun it again. But let's try to access this application. So what I will do now, perform an ls, and so over here I could see that my application, like within this container, at this mount point location, I'm able to see that my init.txt is available. Let me also try to perform a cat operation in order to see the content of it. Init.txt, and if I do so, you see the init container is running. That this echo statement, that echo message got saved in the init.txt file, which we did in the init container, and from the main container I'm able to access it. So let's, for a quick test over here, let us try to execute one another thing as well. See, after this, sleep for 5 seconds, we'll try to do that, or for 10 seconds we'll try to do that. But first of all, we need to delete this kubectl delete pod app with init. That's the name of the pod. So that's how you delete it, and the deletion is done successfully. And now I will try to reapply it. Apply -f init container this. So this got created. Now kubectl get pods. Over here you see this, the status is init. So currently it's in the initialization phase, and at this point of time, if you want to see the logs of it, of this pod, logs -f, and then app with init, that was the name. So you will be able to see that there are multiple logs that are coming up, like it's for both the log for the init container as well as for your main container. So it's currently waiting for the 10 seconds, and then once that is done, you will find that the main Nginx application, it has already got started off over here. So if I just want to see the logs of my init container, in that case I know that I have two containers. One's name is init script. So if I want to see, so there are no logs available because I haven't logged anything, but for the main app, let's try to see. I'll see that there are a lot of logging activities that take place over here in order to start the Nginx server. That's all about it. Like that's how it is done. In the next video, I will definitely talk about sidecar containers, but just to give you a brief overview, like init containers, they support all the fields that and features of the app containers, including you can add resource limit as well as the volume security setups. However, the resources sharing, they are kind of handled separately in case of init containers, but ultimately the pod that you are running, it shares the resources and the CPU that you're using, they kind of shares it with your existing pod. So does the sidecar containers, they also do the same. And yeah, like if you want to specify multiple init containers, so kubelet takes the responsibility of running each of these containers sequentially, and each of the init container, they need to succeed in order to go to the next run, so that the next init container can run successfully. So this is how happens. And once all the init containers have run successfully, kubelet then initializes the application containers of the pod and runs them as usual. So that is what the difference between the regular containers. In my next video, I will talk about the sidecar containers, and we'll try to find out the basic difference between the init and the sidecar containers. That is all for now. Thank you for watching. Have a lovely evening ahead.